This is Jack Jackson. In this section, we will introduce the built-in programs or apps for computing t-intervals on a TI graphing calculators, both a TI-84 and the TI-nspire. They work almost identically to the ones we looked at earlier for z-intervals. And of course, this is so slick that they have these things built in for us. So just as there are calculator applications built into the TI-84 and TI-nspire calculators for computing z-intervals and z-tests, we have corresponding applications for t-intervals and t-tests. Here we will look at a couple examples of using the one-sample t-interval application. So if you watched my last video, we did this problem, worked it out sort of step by step without a shortcut. We did use the calculator, but we didn't use any of the calculator app. And we have commute times here for a random sample of Washington, D.C. commuters. We wanted to compute and construct a 95% confidence interval for the mean commute time of all D.C. commuters. This is the same problem we did before. So this time, we remind you, we first had to determine what type of confidence interval of test is needed to check. And so we had to check the conditions are needed to use that type of inference and see that they're satisfied. This is important. This is the first thing you always have to do. And here we notice that we're constructing a confidence interval for the mean of the population. We have a sample size of 32, greater than 30, so the distribution of sample means is approximately normal. Population standard deviation is unknown. These are the conditions for a t-test. We put our data in L1 in that TI-84 or in a spreadsheet in an nspire. Here I named it time and nspire. Here, of course, it's just called L1. For TI-84, press Stat, left arrow to tests, or right arrow twice, and go down here till you find the one you want. It's number 8, t-interval. You can either arrow down and then get down here on the 8 and hit enter, or if you know it's 8, or as soon as you see that it's 8, press the number 8. And it will pull up this screen here. It asks you if you have their data entered somewhere or if you have summary statistics computed. In this case, it's data. So you click on data. Our data was stored in list 1, so we type in L1 there. That's second 1. Frequency will always be 1 for mine because I'm not giving you frequency tables. If you had a frequency table and L1 was your data and L2 is the frequencies, then of course you would put L2 there. But for us, it's just 1. We put in the confidence level, it's 95%, so we put it in decimal form, 0.95, and then we hit calculate, and just like that, boom, there's a confidence interval. How slick is that? I mean, that is just awesome. It does the entire process for us. There is the lower limit of the confidence interval, the upper limit, showing, looks like about 5 significant digits each. And then it tells us the mean of the sample. So the sample mean was about 27.2 minutes with the standard deviation of about 10.2 minutes in the sample. And a sample was of size 32. And there's your confidence interval. And so we just write down our interpretation. We're 95% confident that the true mean is somewhere between, say, 23.532 minutes and 30.905 minutes. Or we could just say somewhere between 23 and 31 minutes. The TI-nspire works the same way. You go to statistics, go to menu, statistics, confidence intervals, t-interval. So if you know the short numbers, or if you just type the numbers, you could do menu 662. And that gets you to here. Again, you choose data or stats. With this dialog box, we'll choose data, click OK. Our list, we had the name of the list was time, if you remember, so I do the click on this right over here, and the drop down box will tell you, will come up and you'll pick time from the options there. Frequency list, again, is 1, confidence level, put in 0.95, just like we did on the 84. Click OK, and it comes about in a matrix this time. It says it's a t-interval. The lower limit of your interval is here, and it gives more digits. The upper limit is here, it gives more digits. The X bar is here. The margin of error, which I've been just calling E, is there. Degrees of freedom is sample size minus 1 is 32. This is the standard deviation of the x values from our sample. And so that's it. And this is our sample size. And so it returns a few more things than the other one does. It doesn't return the interval in an interval form, but it gives you the upper and lower with actually more accuracy, more digits than the TI-84 does. All right, so now that you've seen that, let's have you try one. A random sample of 40 homes from a town were found to have an average value of $92,460 and a standard deviation of $5,200. Construct a 92% confidence interval for the mean value of all homes in the town. You work it out. Come back when you have it done. Press pause now. Well, hopefully the first thing you try to do is decide what kind of interval this is. Of course, this is in the t-interval section, and it says t-interval at the top, so that's a pretty good clue. But we really need to check things. We're doing a confidence interval estimate for the unknown mean of a population. The sample size is 40 here, greater than 30, so the distribution of sample means is approximately normal, and the population standard deviation is unknown, exactly what we need for a t-interval. We do it on our calculator like this. Do stat test. This is for TI-84. Choose number 8, t-interval. This time we have summary statistics, so we hit stat. X bar is right here, 92,460. S sub x is $5,200. N is 40 right there. Confidence level right there, 0.92. Calculate. There's our interval, our X bar, our S, and our N. Of course, those three numbers we typed in this time. The new information was the X bar. So we're 92% confident that the homes, the mean value of a home in this town is somewhere between $90,982 and $93,938. The TI-nspire works the same way. You go to menu, statistics, confidence intervals, t-interval, choose statistics, enter in your values there of X bar, S, N, and the confidence level, click OK, and it produces this. This is your lower and upper limits for your confidence interval. Of course, we might round that off. Okay, so really, what's happening here is the calculator is doing all of the calculation. I mean, 100%. So the only thing you have to do is decide which type of thing are we doing. Are we doing a confidence interval? Or are we doing a hypothesis test? Are we doing a 1 sample? Are we doing a 2 sample? Is it a T? Is it a Z? You have to make those decisions based on what you know about the different conditions of those tests. Then once you pull up the appropriate thing from the calculator, whether you're using an nspire or a TI-84, choose the right one from the list, enter in the appropriate things. So then you just have to match up the numbers in the problem to the right ones here. Calculate, it returns the answer, and of course the only thing left to do is write down the answer and interpret it. In this case, the 92% confidence interval for the mean value of all homes in the town is $91,982 to $93,938. So we are 92% confident that the true mean home value is in this interval. Once again, it's not that the mean value is moving around. The true mean value is some number. We just don't know what it is, but it's fixed. And if we were to do this process again with a different sample, we would get a different confidence interval, but it would end up to have the same width if we were taking the same confidence level and the same sample size. And 92% of the time, if we did that, we would capture the true mean.